I will give you a brief introduction to the ultra-precision mold padding welder manufactured by Sanwa Shoko Company Limited. This is the WeldPro SW-V01, which accommodates 5 new functions as well as resistance welding and precision TIG welding functions. First, I will show you the optional accessories available for the unit. This is a torch stand. It is used to fix the torch for safe, secure TIG welding by anyone. This is a 10 times microscope. A flexible shaft is used, so you can see anywhere you like. You can protect your eyes by using the shield. This is a halogen light source. With its double arm, it is possible to illuminate anywhere you like without casting a shadow. This is the shielded side. It detects lights generated by an arc and works as a shield for the arc. Next, I will explain the welding materials. .15, 0.25, 0.35, 0.45, 0.65, and 0.85 wires are offered according to the requirements for each type of repair. These are plate materials. We offer plate materials in 0.1 mm and 0.2 mm thicknesses. This is porous metal. This is yarn metal. This is powder material. Both the yarn metal and the powder material melt smoothly and are easy to use. I'm going to explain the new user-friendly functions of the SW-V01. This function is called the Ultra Precision Mode. By selecting Fine on the front panel, you can weld very fine parts. This function is called Weld Navigation. This convenient function offers adequate welding current and welding time by selecting the welding location and the size of welding material on the front panel. This function is called Condition Save Mode. In addition to the automatic setting of the welding time and welding current, operators can save up to 3 original welding patterns. Of course, you can call out custom configurations anytime. Settings can also be overwritten. This function is called Continuous TIG Mode. This function allows continuous TIG welding in a constant interval and is convenient for welding a wide dimension or a long distance. You can set intervals between welding operations in a range from 0.1 seconds to 2.0 seconds. Using this mode, impacts of heat become smaller than TIG welding, and welding surfaces smoother than laser welding can be achieved. This function is called Lead Arc Mode. By applying a minute 2 ampere arc to welding points prior to actual welding operations, you can easily weld the appropriate points. Now, I will show you actual welding operations using a welding machine. During the demonstration, you will see that an operator uses a copper plate. It is used to avoid shrinkage by having the copper plate absorb the excess heat during welding operations. I will show you how to repair parting lines using wire materials. First, join the welding materials temporarily by using the resistance welding mode. In this case, use 2 wires and place one for each side of the parting line. It's easier if you fix 4 or 5 places first to keep wire materials aligned, and then fix them all together. Then place wire materials in a lengthwise direction on both sides to avoid shrinkage. Fix wire materials temporarily in this way. Next, weld using the TIG mode. Start melting the material from both ends and apply a copper plate to absorb excess heat to avoid shrinkage. Make a clearance of around 1.0 mm between the electrode and the welding material. After melting down both ends, melt the middle part of the material. In this operation, move the electrode slowly to overlap the weld bead slightly. Avoid moving the electrode too much, which results in an uneven welding surface. In this way, you will have a perfect welding surface without irregularities. You can confirm that there is no shrinkage or parting lines after grinding the welding surface. I will show you how to repair parting lines using plate materials. First, join welding materials temporarily by using the resistance welding mode. Place welding materials in a lengthwise direction on both sides to avoid shrinkage on the edge. Then, place materials so that half of their lengths stick out of the edge and fix them temporarily. It's easier if you fix 4 or 5 places first to keep the welding materials aligned, and then fix them all together. Fix them securely in this way. Make a clearance of around 1.0 mm between the electrode and the welding material, and start melting down both ends. After melting down both ends, melt the middle part of the material. In this operation, move the electrode slowly to overlap the weld bead slightly. Avoid moving the electrode too much, which results in an uneven welding surface. In this way, you will have a perfect welding surface. Confirm that there is no shrinkage or parting lines. Now I will demonstrate how to fix damage to welding parts on the 3 plain corner wire materials, which are mainly used to fix damage on a corner. Place welding material on each side of the damage so that they stick out of the edge, and fix them temporarily. You can see wires sticking out of the edge in this way. Apply arc between 2 wire materials. Then, the 2 sticking materials are melted and concentrated in the middle, which makes a perfect padding. Confirm that there is no shrinkage or parting lines after grinding. Then I will show you how to fix scratches on a flat surface. First, join wire materials temporarily by using the resistance welding mode. Fix 4 or 5 places first to keep the welding materials aligned, and then fix them all together. In this case, place 1 wire on each end of the scratch. Determine the thickness and quantity of wires according to the size of the scratch. Fix them in this way. Focus on the middle of the 2 wires and weld them together. Make a clearance of around 1.0 mm between the electrode and the welding material. Move the electrode slowly to overlap the weld bead slightly. In this way, you will have a perfect welding surface. Next, I will show you how to fix pinholes. Wire materials are used to fix pinholes in this size. Surround the wire material completely around the pinhole and fix it temporarily. Bend wire materials by applying current in this way, and you can fix the material easier. Fix welding materials temporarily in this way. Weld the middle part in this way. Pinholes can be fixed as shown on the screen. Next, I will show you how to fix damage to inner corners. First, join the welding materials temporarily by using the resistance welding mode. Avoid any clearance between the base materials. Fix welding materials temporarily in this way. In the TIG mode, move the electrode slowly to overlap the weld bead slightly at a 45-degree angle with a clearance around 1.0 mm from the welding material using the continuous mode. Then it is completely welded in this way. Now I'll show you delicate welding operations using the ultra precision mode. I will show you how to perform delicate repair operations applicable to connector core pins. This is a shot using a 10x microscope. 0.15 wires are used for this kind of delicate welding operation. Fix the wire material securely in this way. Start welding operations while protecting the edge with a copper plate. Such delicate welding can be done using the ultra precision mode without melting unnecessary parts around the target points. Then I will show you how to weld the slight edge of the helicoid. This is a shot using a 10x microscope. .15 wires are used for this purpose. Fix 3 wires extended from the target points in this way. Apply copper plates on both sides to avoid shrinkage and weld the 3 wires together. You can see all 3 wires are melted and welded firmly. This is a shot of the damaged edge of a gear using a 10x microscope. Cut the plate material 0.1 mm in thickness, a little larger than the damaged part, and place it so that half of its length stick out of the edge. Fix welding materials temporarily in this way. Apply copper plates on both sides to avoid shrinkage after welding. In this way, you will check the welded part. Next, I will show you advanced welding techniques using the methods I have explained. I will show you how to fix scratches on the slight edge. Cut plate materials around 1 mm in width and fix 3 sides facing the outside as explained during the demonstration for fixing a parting line. Wire material is used for the remaining side. For this kind of repair, it is important to use enough welding material so that it sticks out of the edge as in the repair of 3 plain corners. In this way, fix them temporarily in the same way as for repairs of parting lines or 3 plain corners. Start welding from 4 corners, applying a copper plate on the edge to avoid shrinkage in this way. Then, weld the remaining part using the continuous mode. By making a mount by welding from the surrounding parts, you can avoid damage to the parts other than the target points during welding for a flat surface at a higher power. Weld the surrounding parts in this way. Next, weld the central part. Fix wire material securely, as we did for the welding of a flat surface. Select welding materials depending on the width and thickness of the target points. In order to have sufficient weld overlay after the TIG welding, add welding materials on the welded points in addition to the central part. Fix welding materials temporarily in an equal distance in this way. Next, weld firmly using the TIG welding method in the continuous mode, 1 or 2 wires at a time. Please move the torch slowly to melt the material without error. Avoid moving the torch too much, which results in an uneven welding surface. Scratches on the slide edge can be fixed in this way. You can see that there are no parting lines after grinding. Next, I will show you how to fix nesting and a blunt hole around an ejector pin. Use plate materials for the repair. Temporarily fix the material according to the shape of the hole. Next, weld the welding materials that were fixed temporarily. Apply a copper plate to avoid shrinkage. After melting down both ends, melt the middle part of the material using the continuous mode. Use wire materials to repair scratches remaining on the flat surface. Depending on the size of the scratch, prepare 2 wires. Apply a little extra material than the size of the scratch. When you weld using the TIG welding method, weld in the continuous mode and move the torch slowly. You can see that they are welded firmly and there are no parting lines after grinding. Next, I will show you how to erase stamped characters by welding. First, hit the target point using a hammer before placing welding materials. By hitting the stamped characters, the depth of the depression becomes shallow and you can avoid pinholes after welding. The result is like this. Next, fix welding materials temporarily. Place wire materials so that they surround the part you hit with the hammer. Fix wired materials temporarily in the surrounding area. Fix them on the part you hit with the hammer in this way. Next, weld using the TIG mode. Securely weld 2 wires at a time and move a torch slowly to overlap the weld bead slightly. Be sure to protect areas other than the target area by using a copper plate so as not to melt other stamped characters. After melting down both ends, melt the middle part. For secure welding, increase the current and time settings at this point. This is the result of this welding operation. Next, clad by welding. Use heat-resistant gloves like this for high-power welding. When you use welding materials more than one fight, do not fix them on the target points. Weld by holding the materials in your hand. Use the continuous mode and push the welding material a little into the base material during welding. When you use several pieces of a material to make a thick cladding, put more welding material next to the melted material and push the welding material a little into the base material. You can make the cladding by welding like this, using the steps I explained. Using these steps, the impact of heat is smaller, and there is no shrinkage or parting lines after grinding as you see now. You can weld copper alloy with the V01. Weld without fixing welding materials in this operation too. Use the TIG continuous mode. Push the welding material firmly into the base material during welding. If the welding material does not melt sufficiently, apply some heat by hitting the target point with a hammer. To fix parting lines, align the welding material to the corner and push the welding material a little into the base material. Parting lines on copper alloy are welded well like this. After grinding, you can see that the welding materials fit securely into the base material. As you have seen in our demonstrations, the V01 enables welding of places that could not be done with conventional TIG welding machines or other types of welders. By utilizing the V01, you can save a significant amount of money and time for mold repairs. Please do not hesitate to contact us anytime if you are interested in our product. Thank you very much for your kind attention.